All right, recursive formula. A recursive formula is a formula which is written as a function of prior terms. And believe it or not, we already dealt with one recursive formula. Did you remember the Fibonacci sequence? 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 8, 5 plus 8 is 13. So any term, Tn, is equal to the sum of the previous two terms, where n is greater than or equal to 3. You start with the third term, right? Because the first two terms are your feeder terms. T1 equals 1, T2 equals 1, okay? So this is an example of recursive formula. Notice there are starting terms, check, check. Actual recursive formula, check. Restriction on the variable, check. Okay? So the Fibonacci sequence is an example of a recursive formula. To get any term, we need previous terms. Sometimes we need one previous term. Sometimes we need two previous terms. Sometimes we need several previous terms. In the Fibonacci sequence, we only need two because each term is the sum of the previous two. Okay. Given, okay, now this is getting fancy, okay? There's a restriction on the variable is that, okay? Given f of n, find T2, T3, T4. Okay, well, notice right away, here's our starting term, as said there. The actual recursive formula, as said there. Notice how there are three parts. So there are three parts to any recursive formula. Okay, so now we're ready. We're not going to find T1, that's already given, but T2 is equal to, we have to follow the formula, 2T, 2 minus 1, right, plus 3. So T2 is equal to 2 times T1 plus 3. We know T1 is 8 plus 3. So that's 16 plus 8 is 19. Okay? It's just plugging into the formula. It's nothing to get excited about. So that's T, when n is 2, here you have 2 minus 1, right? That's a funny looking there, plus 3. Okay, let's do T3 equals T, 2T, 3 minus 1 plus 3, and that's going to be 3 times the second term plus 3. That should be 2, right? I'm having senior moments here. 2 times T2, and that's 2 times 19 plus 3, and that's going to be 38 plus 3, and that equals 41. Okay? So T4 is equal to 2T4 minus 1 plus 3. T4 equals 2 times T3 plus 3, and that's going to be 2 times 41 plus 3. That's 82 plus 3, and that equals 85. So there's our T2, T2, T3, T4. See? So notice, to get any term, we need the previous term. It's a recursive formula. Well, look what happens when we have two prior terms, right? Two starting terms. Well, let's take a look. Two starting terms. Okay. So, this is tricky. They're using G, but don't let that fool you. Okay. So, they want us to find G3. Okay, so we're going to use this formula to find G3. So G of 3 is equal to, there should be a square bracket here. I thought that looked funny. Yeah, so we just have to fix that. So we want G of n minus 1 squared plus 4 times g of n minus 2. Just like that, okay? So that's going to be 3 minus 1 is 2, g of n minus 2 squared. Sorry, that's not good. We should be writing 3 minus 1 squared, right? Because n is 3. So we have 3 minus 1 squared plus 4 times g of 3 minus 2. So this is going to be, just write it like that. Don't forget your square brackets. That's going to be g of 2 squared plus 4g of 1. So we know g of 2 is 3, and that's squared. And then g of 1 is 1, so it's 4 times 1. So 9 plus 4 is 13. That one's a little bit tricky, isn't it? Let's do a g of 4, and hopefully it'll... Once, yep. Do you want me to pull it down or slow down? Both?
Would I know the g times 2 squared? How come it became 3 squared?
Well, g of 2 is equal to 3, so I subbed it in. So g of 4 equals, let's see, g of 4 minus 1, right? All squared plus 4 times g of 4 minus 2. I'm doing overkill with the brackets, but it still is good. So we want g of 3 squared plus 4 times g of 2. So we know g of 3 is 13, and g of 2 is 3. So and that is equal to 169 plus 12. That equals 181. See, notice the restriction is n is greater than or equal to 3. So we start calculating the third term because g1 and g2 is given. Can I explain anything better there? It's just a, pardon?
Sorry, this is mostly for like communication, but for example, instead of writing g parentheses 4 minus 1, can I just write g3 something, or do I have to?
Yes,
Where
you
it
can.
comes from?
I'm just showing you where it comes from. If you jump to this line, that's fine. I'm perfectly good with it. No sense killing ourselves if we don't have to. Ah, T1 equals 5. Tn equals Tn minus 1 plus 6. They're giving you a recursive formula. Okay. Find the next 3 terms. Determine an explicit formula for Tn. An explicit formula is a formula used to calculate terms in a sequence without needing to know any previous term. So, well, let's do it. So let's find the next 3 terms. We'll determine whether or not it's an arithmetic sequence, and then we'll determine the explicit formula. Okay, so T2 equals T1 plus 6. We know T1 is 5. So T2 equals 11. T3 equals T2 plus 6, and that's 11 plus 6, and that equals 17. They say the next 3 terms, so we have T1, we have T2, T3, we have to do T4. T4 equals T3 plus 6. T3 is 17, and that is equal to 23. Okay, do we have an arithmetic sequence? Huh? How do we know? 23 minus 17 is 6. 17 minus 11 is 6. 11 minus 5 is 6. We have a common difference, right? We have a common difference of 6. 6, okay? So we know A equals 5, D equals 6. Now we can find our explicit formula. So Tn equals A plus n minus 1 times D. Tn equals 5 plus n minus 1 times 6. This is the formula you learned yesterday. Tn equals 6n minus 1. This is our explicit formula. We do not need prior terms to find any other term.
Is it not? Oh, I see.
Now, this is harder. This one I'm going to skip because this involves a geometric sequence. We just have, if T1 equals that, Tn equals 3/4, and n is greater than or equal to 2, I think we have to chop this out. It's a typo. It's from the previous question, so just block that off. Find the next three terms, determine an explicit formula. This is actually a geometric sequence, and we'll come back to this later. We will do it later. Do it later. Now this is really hard because when we're giving a sequence and we want to find the recursive formula, in general we multiply, divide, square, cubes. We just have to play with it until we see a pattern. First thing you can do is look for the difference. Do you notice the difference between 2 and 5 is 3? And the difference between 5 and 14 is 9? And the difference between 14 and 41 is 27. Do you see a pattern? 3, 3 squared, 3 cubed, right? Okay. Does anyone see a recursive formula here? What do you think? Do you see that this term equals 5 plus 9, and this term equals 14 plus 27? Okay? These are not easy to do. Sorry? 3 to the, yeah. Okay, so let's see. Tn equals t to the previous term, right? 5 equals the previous term plus 3 to the n minus 1. So watch. Okay, so n is greater than or equal to 2 and t1 equals 2. So watch. Let's see if we can find the second term. T2 equals the previous term plus 3 to the 2 minus 1. That equals 5, right? Because 3 to the 1, 2, right? T3 equals the previous term, 5, plus 3 to the 3 minus 1. So 5 plus 9 equals 14. So coming up with this, these are the toughest questions. There's another formula that would work for this. Another one. Can anyone see another one that might work? Another formula that might work? Okay. Notice, do you agree that 3 times 2 minus 1 equals 5? 3 times 5 minus 1 equals 14. 3 times 14 minus 1 equals 41. So here's another formula. Tn equals 3Tn minus 1. It's hard, I know it's hard to see these patterns. So n is greater than or equal to 2, T1 equals 2. Remember, a recursive formula has 3 parts. You guys have any ideas for B?
Ms. Kaczynski, if you gave us such a question on the test, would you expect us to get both of them?
But no, just one. Have a great game. Yes. Yeah, good for you. Tn equals Tn minus 1 cubed plus 1. So 1 cubed plus 1 is 2. 2 cubed plus 1 is 9. 9 cubed plus 1 is 730. Don't forget, you also need your feeder term, right? And n is greater than or equal to 2. It's, huh?
We gotta slow down. Do we just gotta try and figure it out?
Yeah,
How
yeah.
did you just...
You,
I'm lost right now.
yeah, it's a matter of looking at it. Well, if you have to just try. If I square it 1, I get 1. No, well maybe no. If it's a matter of playing with it. It's a
Basically guess and check.
guess and check.
But will you make it like relatively easy on you guys?
Yeah, but yeah, we'll make it. I've started looking at our first draft of the test. It looks pretty straightforward.
You want to show us the first draft?
You tell me if you approve of it.